This is Mrs. Dawson, and the following is an example on how to identify linear relationships. Part-time job. The amount of money Rodrigo earns is shown for different numbers of hours worked. Is the relationship between the amount earned and the hours worked linear? If so, find the constant rate of change. If not, explain your reasoning. Let's investigate what's in the table. We see that if Rodrigo works 5 hours, he earns $70. 10 hours, he earns $140. For 15 hours of work, he'll earn $210. And for 20 hours of work, he'll earn $280. The number of hours increased by 5 each time in our table. So our change in the number of hours, is plus 5, or a positive 5. The amount of money he earned also increased, but it increased by 70, another increase of 70, and another increase of 70. So the change in the amount of money Rodrigo earned was $70. Because our change in x was a constant 5, we'll call this an x, and our change in the amount of money earned was a constant 70, which we typically would call a y, we can find that it is linear. Once again, we have a constant change of 5, and here we have a constant change of 70. The rate of change is constant, so it is linear. The rate of change can be found by taking the change in the amount of money, amount earned, which was $70, and dividing it by the change in the number of hours. Which was 5. Once again, this was the change in the amount earned divided by the change in the number of hours. $70 divided by 5 hours would be $14 per hour. This means that Rodrigo earns $14 for every hour that he works.
Proportional relationships. Today we're going to look at identifying proportional relationships. Look at the graph to determine if there is a proportional linear relationship between a temperature on the Celsius scale and a temperature on the Fahrenheit scale. The ordered pairs represent a Celsius temperature and its corresponding Fahrenheit temperature. For example, 0 degrees Celsius is the same as 32 degrees Fahrenheit. Since the graph of the data forms a line, the relationship between the two temperature scales is linear. This can also be seen in the table of values created using the points on the graph. The table shows the constant rate of change, which is the change in degrees Fahrenheit over the change in degrees Celsius. The change in degrees Fahrenheit is 5. The change in degrees Celsius is 9. So the ratio is 5 over 9. There is a constant rate of change, which also indicates the relationship is linear, but is it proportional? To determine if the two scales are proportional, express the relationship between the degrees for several columns as a ratio. We'll use the ratio degrees Fahrenheit over degrees Celsius and use some of the points from the graph. We'll start with 37 degrees Fahrenheit and 9 degrees Celsius. When we divide, we get approximately 4.11. The next pair is 42 degrees Fahrenheit and 18 degrees Celsius. Our constant rate of change is approximately 2.33. Let's try 47 degrees Fahrenheit and 27 degrees Celsius. The ratio is approximately 1.74. Our final set is 52 degrees Fahrenheit and 36 degrees Celsius. This is approximately 1.44. Since all of the ratios are not equal, a temperature in degrees Celsius is not proportional to the same temperature in degrees Fahrenheit.